How to balance a rear-wheel drive shaft on the car. First, remove the rocks and debris from the tires. Rotate the tires and look for any rocks. The rocks will fly out during rotation. Someone might get hurt if a rock hits them. Next, we need to fabricate a vibration sensor. Here I'm going to use some strapped steel, a couple of magnets, a sheet metal stand, and a plastic cup, a clear one, so that I can see the water vibration. Check the vibration and locate the heavy spot. So we're going to spin the car up and we're going to watch the cup as I place the magnetic sensor onto the differential. Here we see the vibration from the drive shaft is just shaking the water like crazy. This is unacceptable. As you can see, I'm spinning the wheels approximately 65 to 70 miles per hour. And I'm using a pedal press to hold the gas pedal down so I can do this myself without the aid of an assistant. Now I'm going to hold a piece of chalk very close to the rotating drive shaft until it just barely touches the drive shaft. After I stop, I can see the heavy spot where it has marked the drive shaft. And the black tape is where I placed a counterbalance to make sure the drive shaft was out of balance for this exercise. Now we're going to install two hose clamps for counterbalancing, and then we're going to position them opposite the heavy spot. Here, put the hose clamp around the drive shaft and mark the end point. Now take a pair of snips and cut the end off of the hose clamp. You want to do this with two hose clamps because we're going to use two of them to balance the drive shaft. Find the heavy spot and place the hose clamps onto the drive shaft. Once the hose clamps are over the drive shaft and just snug, we're going to position the head of the hose clamp exactly 180 degrees from the heavy spot. Here I've just used my finger and my eyeball to determine where 180 degrees are at. Place the head of both hose clamps at the same spot and tighten them. Now we're going to compress the suspension before we check for vibration. Lower the car down on a couple of jack stands so that the suspension is compressed and the drive angle is correct. Now spin the drive shaft up and watch the cup and see what the water does. Every time the car shifts, you can see the water taking off like crazy. We're going to wait for it to stabilize so that we can see the vibration. Now that we have reached cruising speed, we notice that the water in the cup has stabilized. You still see some vibration. We might be able to improve on this, so we will continue on to the next step. Stop the vehicle and we will readjust the hose clamps and do another test. We're going to spread each hose clamp a little bit in opposite directions. And just so we know where we started, we're going to put a 0 mark on the drive shaft with a piece of chalk. Now, spin the drive shaft up again, running approximately 65 to 70 miles per hour. You can tell when the car shifts. The water goes crazy for a moment. We'll let it stabilize as we zoom in to look at the vibration of the water. Seems a little more than previous. So we're going to readjust our hose clamps again and check. Step 7. Readjust the hose clamps and retest again for vibration. Now let's mark our hose clamps to position 1. This will help us keep track of where we have moved our hose clamps. Since the vibration seemed worse, I'm going to move the first hose clamp back closer to the 0 mark. And I'll do the same thing with the second hose clamp. Make sure the hose clamps are tight, and let's spin it up again. We'll run it up through the gears and let the water stabilize when we hit approximately 65 to 70 miles per hour. Now that we're stabilized, we can check the vibration in the water. Better, but still a little bit rough. Let's proceed to the next step. Step 8. Readjust the hose clamps again. Let's place the first hose clamp back on the 0 mark. And spin it up again. And once it's stabilized, we'll zoom in. This looks better. We're going to try one more time to tweak it to see if we can make it even better. So step 9, readjust the hose clamps one more time, and let's do a retest. Now I'm going to move the second hose clamp back to the number 1 position. There we go. Now, let's start it up again and give it a spin. As it goes through the gears, the water jumps around like crazy. So we have to let it stabilize. That looks pretty good. You'll never get a perfect smooth glass of water. But let's try just a little bit more, just to see if we can get it better. I'll spread the second hose clamp just a tiny bit further apart, just to see if we can improve upon that last setting. We don't want to miss anything. Alright, let's fire it up again. Now that it's shifted through all its gears and hit its maximum speed, let's take a close look at that vibration. In my opinion, the vibration got a little bit worse. So our last adjustment was our best adjustment. Let's take the final step and put the hose clamps back to the last position we were at and do a final test. Okay, let's spin it up one last time. Here you can see at 75 miles an hour. The glass is about as good as we're going to get it. Nice and smooth. Your drive shaft is now balanced. Leave the hose clamps where they're at.